All right, let's get started with Lesson 5, Significant Figures. Now that we understand the measurement system that we're going to use in chemistry, the SI system of units, we can now ask a very important question. Once I make a measurement using some instrument, how many digits do I actually record for that measurement? Now, this is a really good question and one that we're going to address in Lesson 5 today. So first of all, in answering that question, you must understand that every instrument that we use to make a measurement actually has limitations to it. There is no such thing as a perfect measurement instrument. All right? Because of that, there's always going to be uncertainty or estimation in the measurement that we actually make. So I want you to think about that because that's really important to understand. All right. Now, why is this the case? Again, because every measurement device that we use has limitations. Now, the limitations in the instrument affects what we know as the instrument's precision of that instrument or the number of possible digits that can actually be recorded for that measurement. All right. Now, the digits that can be recorded for any measurement is known as significant figures, or for short, we call them sig figs. Now, sig figs will always include the digits that are certain. These are the digits that we agree on, everyone agrees on. Regardless of who uses the measuring device, we will all agree on certain digits. And then we must include always one uncertain or estimated digit in any measurement that we make. Together, the certain digits and the estimated digit make up the significant figures. So we can look by definition then, is that significant figures, by definition, when recording the correct number of digits for any measurement, always include all the certain digits that everyone agrees on, plus the one estimated digit. And the estimated digit must always come at the very end of the recorded measurement. So for instance, let's say I put down a measurement value from a lab. Let's say that I measured the mass of some object and it turned out to be 2.46 grams, okay? Now, these two digits that come first, the 2 and the 4, are going to be known as our certain digits. That means that everyone should agree that the object has a mass of at least 2.4. But the digit that I'm underlining here, the 6, is our estimated digit. That is the last digit. And that is the digit that we may not agree on. In fact, someone else might find that it is 2.45 grams or 2.44 grams, okay? And that is okay, because as long as we agree that the 2 and the 4 are correct digits and that the last digit can vary or be estimated because it is uncertain. And why is it uncertain? Again, because there is no such thing as a perfect measurement instrument. They all have limitations to how good they can make a measurement. All right? So let's take an object here. We have a wooden rod here that we're going to measure the length of. And we have a measuring instrument, a meter stick, it looks like. And so on our meter stick, it has some dramatic limitations. So we know that the meter stick here is 0, and at the end it is 1 meter. So if we look at our piece of wood here, it has a length that ends there. So we know that, of course, that the wood is greater than 0 meters, but has to be less than 1 meter. All right? But do we know really any certain digits? The answer really is no, other than the fact that we know that it's greater than 0. So we know that it's at least 0 point something. All right? So at this point, why don't you guess what that next digit might be? All right. According to this diagram, the author is going to estimate that it's 0.6, but you might estimate that it's 0.7 or maybe 0.5. I don't know. But the point is that the first, this last digit here, we're not going to necessarily agree on. It's estimated, all right? So we don't really have any certain digits in this particular measurement due to the limitations of this meter stick, all right? So this is not the best instrument to use. So let's say we're going to get us a better meter stick, and this time it's going to divide into smaller units. So we still know that this is the 0 mark, and we know that the end is 1 meter. But now notice that we divide it into 10. So we got 10, 20, 30, and so forth, okay? So now we can get a better idea of what this measured value should be, okay? So that's the end of the stick. Actually, let me erase that to make it a little bit clear here, somewhere in there. So now we know that not only is it greater than 0, but now notice it's greater than 0.6, okay? So everyone that makes this measurement should know that they should agree on the 0.6, okay? Definitely on the 0.6. But after that, all we know is that the stick is greater than 0.6, but less than 0.7. So now the second digit that we're going to record here is going to be the estimated digit. Now we just can't leave it at 0.6. We actually have to estimate one additional digit. Now a lot of students forget to do this. They just record the certain digits that they know and forget to record an estimated digit. So according to this author, they're estimating 0.61, and that's probably pretty close. You might say it's 0.62, and that's okay, because again, all you're doing is estimating your best guess of what that last digit is according to the limitation in your instrument. All right, but we can do better than that. We can get a measuring instrument ruler that's even better than those first two. And so this last one, what we will notice again, our 0 mark, our 1 meter mark, and here's the end of our piece of wood. And so from here we can see that it's definitely, again, 0.6 for sure. But then the next mark here, this little small mark, is actually 0.61. So our range has to be then, if we were to, sorry, let me erase this. Our range for our stick, how long it has to be between 0.60 and 0.61. So we have to estimate somewhere in between that. So we know that it's definitely 0.60, and then the next digit is going to be very hard to estimate precisely. So the author says they think it's 0.607, but I certainly might say it's 0.608. You might even say that it's 0.609, okay? And that's okay as long as we agree on the 0.60 and then we estimate that last digit, okay? And that's pretty much how we measure or put down the correct number of digits or significant figures when we record a measurement, okay? And it all is really based on how good our measurement device is. All right, so now let's turn to volume, okay? So this is a graduated cylinder, and this graduated cylinder is measuring some kind of liquid. So it looks like the graphic is going to kind of increase the dimensions of this graduated cylinder so we can take a better, closer look at the volume here. The correct way to measure the liquid in a graduated cylinder is at the bottom of the meniscus. Now you'll notice that there is sort of a meniscus here where it bows up a little bit, okay? So when you make a measurement, you want to do right at the bottom of that meniscus, okay? And that will give you the best measuring, or best measurement recorded. You don't ever want to measure at the top. This is a no-no, just at the bottom in that meniscus, okay? So let's take a look at what we think it might be, okay? So notice that we have 15 and we have 20, okay? Now, the units of these are in milliliters, okay? So we know that our volume comes between 15 and 20 milliliters, okay? So we definitely have to agree on the 15, all right? But it's less than 20. The question is, what are these hash marks going up by? So we have 15. The next hash mark, what do you think? Is it going up by 1? So this could be 16, 17, 18, 19, 20. And it looks like that's correct. It's going up by 1s. So we know that this is 16 milliliters. This is 17 milliliters, 18, 19, and then that 20. So now we can do further better idea of our measurement, because we know that this is the 15 mark, 16, 17 mark, okay? So at this point, we know that at least has to be between 17, but less, because we know that that's 18, but less than 18 milliliters, okay? So we further define our measurement much better by looking at these hash marks. So at this point, we know that it definitely is 17. And so now what we're going to do is have to guess the next digit. So it's going to be 17 point something. And so I'm going to guess that it comes sort of a little bit there. So I'm going to say about 17.8 milliliters is what I'm going to guess that answer to be. Now you might, and hopefully you do agree that it is 17, but you might say that it's 17.7 milliliters, or maybe it's 17.9 milliliters, or somewhere in there, okay? So again, we should all agree on the 17, but the last digit is estimated, and we might very possibly disagree on that due to the limitation in the graduated cylinder, all right? So in this case, what we would say is that we can measure to 3 sig figs here. 3 significant figures. That's the best number of digits that we can record to, is the 3 significant digits. All right, here's another graduated cylinder. Let's see if we can get a better idea of what we might be dealing with here. All right, so we have a liquid. We definitely know that we have a 50 and a 60. So this is 60 milliliters, and that is 50 milliliters. So we know that our liquid value is greater than 50, but less than 60. But we can get better than that because we have some additional hash marks there. And I think we're going up by 1s again. So I think that this is representative of 51. That this hash mark here is 51. The next one is 52, and then we have 53, and then that should be 54. And this one that goes out a little bit further, should be 55 milliliters, okay? And then we can go up from there. But we don't need to, because we can see that the bottom of the meniscus is roughly right there. So to me, looking at this, well, I'm going to erase this so we can see this a little bit closer. There's the meniscus. So to me, if this is 51, and that's 52, and the next one then is, hash mark is 53, right? So that would be, oops, That's 53, okay? So to me now, I can further define that the liquid is a range of 52 milliliters to 53 milliliters, okay? So it's got to be greater than 52 but less than 53. So that means for certain we should agree that the volume is at least 52 milliliters. But the next digit, because there's no more hash marks to divide, we're going to have to estimate something. So we're going to have to estimate it to the first decimal place. So I'm going to estimate it's about 52.8 milliliters. And you certainly might say it's 52.9 milliliters or something around like that, okay? So we should agree on the 52. Make sure that we do. And the last digit, of course, is estimated. So how many significant figures do we have here recorded? Again, that would be 3 sig figs, because we can only record 3 digits in our final measurement. All right? All right, so now we have an electronic balance. Now, the electronic balances are a little bit easier because they actually give us the number of digits for our measurement. So we like electronic balances or digital measuring devices because they give us better or easier ways to measure. Okay, so this balance here, this first one, back up. This first balance here is recording 0.18895, okay? So what that means here is that we can agree, the balance can agree, and everyone else should agree that the measurement is at least 0.1889 grams, all right? And then the last digit here, the 5, the balance itself, the computer estimates. So even in a digital piece of equipment, the last digit that you would record is estimated. So the next time you actually measure this, it might actually say 0.18896 grams, all right? Because the balance itself is doing an estimation. The better the balance is, the more likely it's going to be consistent in estimating that last digit, though, all right? So how many significant digits does this balance record? We have 1, 2, 3, 4, and 5. So 5 sig figs this records. Now you say, well, what about the 0 here? What's going on with that 0? Why didn't we include that in our number of sig figs? It's because that 0 is not significant. That 0 is only a placeholder. A placeholder just helps us to understand what value our first significant digit really is. So in this case, it just tells us that our first significant digit is in the 10th place, all right? So zeros sometimes are not significant figures at all. They're just more or less placeholders, and we're going to talk about that a little bit more in just a minute, okay? Now, if we look at this other balance here, it records a mass of 93.14. That means the first 3 digits are certain digits, and the last digit, the balance, again, is estimating that that is a 4. So in this case, we could say that all these digits are significant, and we have 4 significant figures in this measurement, okay? Hopefully that makes sense to you. We'll practice a lot of this in class. We'll do a short mini lab to help us to record correct numbers, significant figures when we take some measurements. All right, so finally what this leads to is what we call significant figure rules. Now, significant figure rules help us to determine which digits in a recorded measurement are significant and which ones are just placeholders. And so in other words, we're just really looking at zeros here. We have to determine if a 0 is a placeholder or if it is a significant digit. And so we have some rules. There are 5 rules listed in your notes. We are only going to talk about the first 4 in this lecture video, and the last rule there we will discuss in class, okay? So first of all, the first rule just simply states that any digit that is a non-zero digit in a measurement is going to be significant. So for instance, we have a measurement of 123 grams. All of those are non-zero digits, therefore we can assume that this measurement has 3 sig figs, that they're all significant. However, which one is estimated? If you guess the 3, you're correct. So 123, the first 2 digits are certain, and the last digit is estimated for this measurement. Okay, so let's look at rule number 2. It gets a little bit more complex now. Zeros that come before the first non-zero digit are not significant. Okay, what does that mean? That means that these zeros right here that come before that first non-zero digit are just placeholders. So these zeros right here are never ever significant. All right, the first significant digit comes when we hit that first non-zero digit. So in this case, we only have 2 digits that are significant. So we call these 2 sig figs. All right, and the first digit that is significant, the 1, is certain, and the 2 is going to be our uncertain or estimated digit. If we look at this next measurement, these 2 zeros are not significant because they come before the first non-zero digit. So that means that this measurement here only has 1 significant figure. All right, those other zeros are just placeholders. It just tells us the value of where our first significant digit lies. All right, and it also, in this case then, if that 1 is our first significant figure, it is also our estimated digit. All right, erase this. Let's look at rule number 3 now. Rule number 3 says that zeros that become between non-zero digits are significant. Okay, so what that just tells us is that 0 and that 0, both of those are flanked by 2 non-zero digits. So therefore, these zeros are not placeholders, but they must be significant. So in this case, all the digits are significant. So that would be 1, 2, 3, 4, 5. So we have 5 sig figs for that measurement. Again, which digit is being estimated in that measurement? Which one? That's right, 3. This last digit is our estimated digit. All right, now let's take a look at this other measurement. Now we have 2 zeros that come before the 5. Are those going to be significant? The answer should be no, because of rule number 2, those 2 zeros are not significant. They are just placeholders. But this 0 that comes in between the 5 and the 3 is significant. So therefore, this measurement has 3 sig figs. And the 3 is the estimated digit. All right, hopefully you're kind of seeing how this works. All right, of course, we'll give you tons of practice on this in class. Now, the last one we're going to look at, this is probably the most challenging one for most students, okay? And that is zeros that follow non-zero digits are only significant if there's a decimal point given in the measurement, okay? So let's talk about this for a minute, okay? Let's look at our first measurement. Notice that we have 2 zeros that come at the very end of the number. The question is, are those zeros placeholders for the 4, or are they actually significant digits? The answer lies, is there a decimal point? And there is. What that tells us then is that those zeros are indeed significant. So this measurement has 3 significant figures. Oops. Okay. Just because there is a decimal point there. All right. Now, what is the estimated digit? That would be the last zero then. Okay. But what if we have a measurement that is 400, but notice again there are 2 zeros that come after the 4. The question is, are those zeros significant? In this case, no. Why? Because there is no decimal point at all, period. So therefore, this measurement only has 1 sig fig. And the 4 is the significant digit, and it is also the estimated digit. All right? So, zeros at the end of the number are only significant as long as there is a decimal point somewhere in the measurement. It has to be somewhere. It doesn't necessarily have to be at the end. For instance, let me give you one more example and then we'll be done. Okay? Let's say I have a number measurement of 0.0710. Okay? The question is which zeros are significant? Well, the first 2 zeros cannot be. They're just placeholders. All right? And we know that from rule number 2 that any zeros that come before a non-zero digit are insignificant. They are just placeholders. So that means the 7 is our first significant digit. The question is, what about that last 0? Is it significant or is it a placeholder? The answer is, or the question you have to ask yourself is there a decimal place in this measurement? The answer is yes. It comes towards the beginning, but there's still a decimal point. So therefore, that 0 must be significant. And we would say that there are 3 significant figures in this measurement, with the estimated digit being that last 0. All right? So you always have to look and ask yourself, is there a decimal place? If there is, or a decimal point, if there is, then the zeros at the end are significant. All right? So hopefully this helps. I know this video went a little bit longer than I was hoping for, but significant figures are very important for you to understand. You're going to be using these not only in your labs to record data, but you're also going to have to record the correct significant figures in all your tests, homework, and quizzes. All right? AP and IB are very particular about correct number significant figures. All right? So that is all for now for this video.